Hey there viewers, thank you for tuning in to Supermariodiagnostics once again. Today we are working on a 2014 BMW X5 with the 4.4 twin turbo engine on it. And its concern is a flashing check engine light and a misfire. And it came from another shop and they went ahead and replaced some parts. We'll get to what those parts are once I uncover this thing. First things first, I put a maintainer on it. These things, they can be pretty power hungry when you leave the key on with the engine off. I already did a pre-scan, and this is what the pre-scan shows. Shows everything is good except for 5 codes in the DME2. Showing cylinder 5 ignition combustion period too short, several misfires detected, cylinder 5, fuel injector switched off, you know, cylinder deactivation as a result. Yeah, so looks like we're going to be maybe looking at number 5. I will first want to see which one is our number 5 cylinder. For that, we're going to need to go to service information. So put you guys over here, and of course I didn't start my screen recorder yet, so I will now. I already have my service information pulled up, and of course I have to sync the screen recording with the camera, so there we go. We are synced. We are now in service information and we want to look for cylinder 1, so usually I'll type in the search bar cylinder 1. If you're looking for any other cylinder, you don't put in cylinder number 4, 5, or 6. You put in cylinder 1 and see what it pulls up. So here we have an arrangement, and they give you, I guess, for every single vehicle. Since this is a V8, this is the one that we're looking at. So that's number 5 would be the very front cylinder on the driver's side. So let's go ahead and take a look and see and confirm if number 5 is the issue. Since there's cylinder deactivation, we probably have a very limited amount of time between the time that it starts misfiring naturally and the time where it misfires as a result of cylinder deactivation. Of course, to remove cylinder deactivation, we have to clear the code. So we're going to clear the code. I'm going to do that now. The key is on already. And you know what? Let me just go into the module. And we're just going to erase the code. Successfully erased. Read the code. No fault codes detected. We're going to go into the vehicle and recreate the symptom, which I already have recreated, but for the sake of the video, we're going to recreate the symptom. And if I don't sound normal, it's only because I've had a cold. It's not that I'm like trying to be unenthusiastic or anything. I just yeah. Anywho, let's get into the car and see what's going on with this thing. It is a nice car, I'm not gonna lie. We got the ignition switched on, 109,000 miles on the clock. Let's turn off the AC system, and I'm going to hold the brake pedal and start the vehicle. And it's very, very subtle, but it is a V8, so okay. Yeah, I believe that this is where the cylinder deactivation took place because it feels like a dead miss now, but it was very subtle before. And you know what? Let me turn it on again. And we're going to see if it is indeed cylinder number 5. Just pop off this cover. and you can see some trembling. Well, if I could hold the camera perfectly still, you'd be able to see it, but what I'm looking for is cylinder number 5. If I disconnect the coil, will I feel a difference? I feel zero difference disconnecting the coil. So cylinder identification, misfire identification is correct. Now let's find out why this thing is misfiring. You know, for a dead miss with the cylinder deactivated, this thing is very subtle. You could barely feel this thing, because there's so much contribution from all the other cylinders. So anywho, let's put you guys back on the tripod here, and I will walk you through the whole process, my whole process. I would like to start with a primary waveform, if at all possible. So I'm going to leave it running. The injector is off. It's not like it's going to ruin the cat. It's not great for it, but at this point, a misfire is a misfire. I mean, the good thing is that the injector is not just pumping into the cylinder. You know, if we read the codes again, we should see a cylinder deactivation. It's taking a while. Okay, cylinder deactivation, injector switched off. So yeah, for the primary, we're going to need an attenuated signal. So you're going to have to use an attenuator. Don't use anything less than an attenuated probe in order to capture a primary signal. I already have my picoscope set up to my home settings. I will have to set it up for the attenuator, and for that I like to go to X10, so times 10, and I'll just pick a random voltage. And before I go to the bad cylinder, I want to grab a waveform from a good one, at least so I can have the proper voltage scale and all that stuff. So we're going to back probe the coil, and hopefully these aren't smart coils. Every Mercedes that every Benz Beamer that I've had has been without the smart coils. It's been I've been very fortunate to have primary waveforms out of them. So let me just grab my flashlight. And what I'm looking for is the odd man out. Every wire here has a brown and a red. I'm looking for the other one. So in this case, on a good cylinder, it's a red and white. Oh, and my waveform just went off the screen. So let's bring it back. Common mode over range. That's weird. I've seen this before, and it is not good. The last time I had one of these situations, I had to ground the back lug of the picoscope to the car. Alright, so we have a signal. That's weird. Well, you guys saw it yourselves. Whatever. We have a signal from the good coil, which is great. And it looks good, right? Let's go to our suspect. I want to put more time on the screen just to not miss anything. And in this case, it's a white wire. And it is a tight fit, so oh man, I'm trying to get a signal. I'm seeing a change in voltage here, but I can't keep my probe in there. There it goes. I don't see a coil command here, people. Let's zoom in. And it just froze on me. My Pico is acting up so bad. This is crazy. There we go. We're zoomed in and we got nothing. Now, of course, there's always that discrepancy of... Hold on, my voltage was not at 0 before. I'm going to try to move that probe to see if it's moved. There you go. Hold on. This is one of the problems with back probes. I'm going to zoom into, obviously these are not good signals, but I want to zoom into these. And this is just noise. This isn't really anything going on here. This thing is not being commanded to ground. There's no reason why cylinder deactivation would cause this. We have a 14 volt static, but no command. So that's going through the coil. That positive is going through the coil, ignition coil, and to the command side of the coil, and is not being met up with a grounded command. So we either have an open circuit between the coil and the DME, or the DME itself, the transistor that controls this coil, has failed. So there's no cylinder deactivation out there in the world that will turn off spark, that I know of at least. Some manufacturers bound to change that and they're going to make it happen, but yeah, on to the next step. We got to unbury the DME and check the continuity of both from the coil to the DME. So first things first, let's look up where the DME lives. Let's look up control module, and I'm going to turn off the vehicle real quick. And I probably should have put engine control module. You see? Engine control module. Since there's DME 2, that's where the codes were set. There's obviously 2 DMEs on this thing. Let's see where number 5 is. The DME for cylinders 5 through 8. Remove power distribution box. Nice. It's underneath the windshield cowl. Yep. And there's coolant hoses all around it. I believe it is cooled by the cooling system. Yep. If you ever have a leak, a coolant leak, one day you can tell your customer, oh, it's your DME. It's your engine computer, it's leaking. See, okay. So, it looks like it's around that vicinity. So we're gonna have to uncover this. And for now, since I have the engine off, I'm just gonna remove the maintainer. I have everything off already on the vehicle. I'm just gonna remove the maintainer in order to gain access, just for convenience sake. Can't believe my Pico just wigged out on me, man. Sucks. But that's not your problem. Let's go ahead and make some room. Oh, hold on, let me turn off my headlights, because if you want to keep the key-on engine off without it turning off on you automatically, you need to turn on the headlights in this vehicle. And you're gonna want to pull out this little grommet here in order to remove this cowl. And is that the only one? I think so. I'm going to remove this rubber here. And I do apologize in advance for the sniffling. There's a little thing you have to press here. Then you got to remove. You got to lift up over here and carefully get it out without destroying the car. We got some tabs we gotta lift. I believe this is the cabin filter. Oh yeah, we're getting closer. We've got another grommet. I will position you guys in order for you to have a better view. Whoop-ham! That's what we're looking at. So if anybody was wondering, I should just turn on the flashlight as well. Oh, love that. So yeah, that is the area of concern. That extra lighting is nice. We're removing this clip. It's just not nice when I'm looking at it. And which one will be number 2? I don't know yet. I guess we'll find out the hard way. As I do with everything, I'm going to disconnect this AUC sensor, or air quality sensor, whatever you want to call it. And there's something else holding it down. It's probably more clips. It would probably help to look at service information, but I'm hard-headed, and there are some. Hold on. Don't force it. Nice and easy. Gently, or gingerly, as Erico would say. Remove these clips and get the sucker out. I like to stack things on top of each other so that I don't go in the wrong order. It helps. Now let's see how we remove this power distribution box. It would probably be wise to disconnect the battery, but like I said, I'm hard-headed. I can hey, I don't see the coolant lines connected. Huh. So they skimped out on the cooling lines on this one. I kind of don't want to fully disconnect the power box because I'm probably going to end up disconnecting the DME to find out which was number 1, which was number 2. Unless service information would tell me. It doesn't really show very good detail to confidently distinguish which one is which. But if I was to guess, it would be the front one, the one facing me. So how can I lift this out of here? Because it looks like I could just lift it. Huh. And I was right. Except all this stuff is connected and it's holding it down. But being pretty familiar with these DMEs, all the power and stuff, you could just disconnect this one connector and find out if that is the right one. I mean, you could do that. Except in order to disconnect that, I would have to grab it from the other side. Sweet. This one comes free. See, they're not that hard at it. Euros are not that bad. You just gotta get curious and touch stuff. So I'm gonna disconnect this DME and find out if we could talk to it. Talk to number 2 or number 1. The one that we can't talk to is obviously the one that we just disconnected. It seems like if I'm being overly sarcastic, I probably shouldn't be that. But with all the trouble that this car has already given me with my Pico acting up and all that stuff, I don't know. I just don't feel right. Anywho, we're going to try to read codes in DME 2, and we can read codes. So that is DME 1. So let's go back. Let's go to DME 1. Make sure. That's funny. Somehow it is still talking. Bam! Probably wasn't supposed to do that. But you know what? I never had an issue before. So that might be DME 2, unless there's some kind of, like, all this stuff is saved into the gateway and then the gateway just reports. Which, no, I'm just overcomplicating things in my head. Oh. What? That makes no sense. I want to look at live data. This is the Valvetronic stuff right here. I'm disconnecting it completely, people. With the key on. Let's look at live data. I think we're onto something. Just realized you guys can't even see what I'm doing. I do apologize. That was not the intent. Excuse me. Got no data. Nothing comes up. I want to try the same thing on DME 1 just to be sure. Okay, so now we finally lost communication with the DME fully. So now we need to find out which wire is it. And for that, we're going to go to our trusty aftermarket service information. So, what are we going to look for? We're going to look for a diagram. I like to go to vehicles, start fresh. And I'm sorry for giving you my back, guys. It's not my good side. I don't have a good side. My wife says I do have a good side, but I just don't remember what it is. Powertrain management. 11-page long powertrain management diagram. Let's see how dense this thing is. Let's put that logo in there, that shameless plug. And you know me. Oh, look, the ignition coils are right there in my face. I'm just waiting for this thing to finish loading. I can't believe my Pico did that. Sucks. Okay, it is loaded. And we're looking for ignition coil number 5. Mambo number 5, the white wire. That's the one that I mentioned earlier. Let's follow it. And it goes to pin 1. That should be an easy find on 6B, connector 6B, with a red and white next to it, followed by several spaces and then a blue. So we got the red, white, and blue, baby. Let's go in here and find out which one is 6B. Hopefully it won't be too difficult of a task. Let me see something on service info. We have several that have red. Okay, so it's a white pin number 1. So I'm just going to look at each pin number 1 on these connectors. I don't believe it's going to be these giant cables. Pin number 1. Pin number 1. That's red. Pin number 1. And we would have to uncover this in order to find out, but let's keep going. We would have to uncover that too. Pin number 1. And pin number 2 is blue. We have service information says white and then red and white on pin number 2. So pin number 1, nothing. So it's none of these. It's one of these that are covered. I will go with this one. Watch it be the last one. It's always the last one that you check. And I'm going to open up this little sheath and peek inside. Look for pin number 1. And I don't see it clearly, but I really don't think that's it. There's a bunch of red and yellow in there. Probably would have been easier to just look up the service info, but what if you don't have service information, right? You gotta have service information on these cars. I'll tell you that much right now. Alright, so we have this uncovered. We have pin number 1 was a white, followed by the red and white. So we're going to stick a screwdriver in there and spread that pin. Just kidding, don't do it. We're going to stick the proper terminal in there. Or, yeah, if you want to call it that. It's best to start smaller and then work your way up if it comes to that, but you always consciously feel for a nice tension. That's good tension right there, I'll tell you that much. And the pin that it connects to looks good in the DME. And we're gonna load test this wire. How? With a headlamp. I probably like halfway coughed when I said that. What I meant to say was with a headlamp. Oh man, this sniffling makes me sound terrible. So I'm gonna use one of these, right? I'm gonna hook this to ground. Hook it to a good ground. I'm just kidding. Where is my good ground? There's a nice little stud over there, but I'm not sure if it's a good ground. Strut bolts tend to be good grounds. I'm just going to trust that it is. I'm going to assume, even though it's dangerous. And put that right there. And then you guys can follow me along to this side. All right, so we got all this crap in the way. And let me disconnect my coil. And I have a back probe already on it, which was from my scope. And we're looking to connect to the white wire. We're going to use the correct terminal. Anybody else, if you ever see somebody not doing this and they stick a jackhammer in there, make sure you stop them and you tell them why that's wrong, because then it makes it another variable. So what I did was start small, like I recommended. Followed my own advice for once, and I worked my way up. It was too small, and this one has nice, good tension. And luckily for us, look at where my power is. So all I need is an alligator clip, and we're matching. And whoops, that's not gonna work. I don't care what they say. We need a double-ended male to complete the job. All right. And we are lit. So what does this say about our wiring? It is good. Our wiring to the coil is good. I'm going to give it a little shaking. And it does not flicker whatsoever. Ideally, you would want to check with the current clamp and see if there's any variation. There will be, as the temperature changes on the bulb, there will be current changes, but if you see droppage, then that would mean you have an intermittent open in the circuit. So our testing is done. What's wrong with this car? If you haven't kept up with what we're doing with these tests, whoa, ladies and gentlemen, the DME, the transistor or something, fails to command that coil. So how do we fix it? We could put another DME in it, technically, or the less popular opinion would be we can open up the DME and fix the transistor. Assuming that there is a standalone transistor that we could just fix. If it's a smart chip, that may be harder to acquire one of those chips. If it's something that's proprietary to BMW, which I doubt, then we won't be able to fix the DME, but we're going to leave the option up to the customer, to the shop that sent it to us. So we got this sucker open, and I was going to clone it, but I figured why not investigate. I did have this writing down to get the protocol, but we would be able to clone it if we have to. But once I opened it, I saw something that caught my attention. So let's take a look at what we got here. And as you can see, these are our transistors here. These must be for something else, but these all look alike, and I see a burnt one right here. I hope you guys can see this, man. That would suck if you can't. But yeah, that transistor is no good. Now the question is a transistor going to fix this and we're good to go, or is there something else going on? How can we test this? If you guys remember, put this over here so you guys can see better. Leave that right there. Our pin number 1 is our number 5, which is our dead cylinder. I've got a meter that beeps and all I'm doing is checking continuity between stuff, right? So I want to make sure I've got, this is my number 5. It should be on pin number 1. And there are 3 pins on this transistor. There's pin number 1 here. There's no continuity. Wait a minute. There is continuity. Okay. Pin number 2. There is continuity. And then pin number 3, no continuity. But I would like to see if this transistor is maybe an adjacent cylinder. Who knows? It's a good one, definitely, because we know that our number 5 is the only one misfiring. So I'm gonna go and check. I'm pretty sure that this big pad right here is our drain. For those of you who are not familiar, and I'm no expert, by the way, just from the little research I had done, there is a source, a drain, and a gate. So our source would be our supply, whether it's ground, power, whatever you want it to be. Our drain is where it's going. So in our case, the coil, and out through pin number 1. And then the gate would be like the gatekeeper, so to speak. It's the command. It's the one who decides when to close the circuit between the drain and the source. So, and I would hope that there's a diode in between the gate and the IC or the MCU, whatever controls this, for moments like this, because look at it. I mean, only one thing can cause this: overuse, overcurrent, or a short. But I want to test a known good before I actually test my bad one. This known good, I don't know what cylinder it belongs to yet, but we're gonna, I believe the middle one is our drain, so it should have an output to another pin. So what I'm gonna do is see if I could get lucky. I'm going to start with number 1, which it shouldn't have continuity, and we found it on pin number 2, so that's pretty awesome. Pin number 2 is the drain for this good transistor, so that's good news for us. Now, to further our testing, just to show that pin number 2 is also connected to this bottom plate down here, so just remember that. We're going to go to pin number 1. And there's no continuity. Pin number 2 is our drain. It should have continuity. And then number 3, no continuity. Now, one thing we know about, at this point, we only know one thing on a good transistor, is that the middle one is the drain. We don't know which side is the source. We don't know which side is the gate yet. But considering the design, this isn't one of those transistors where, oh, hold on, my meter just timed out. This isn't one of those transistors where it's sending out a 5-volt signal. We know that BMW's, I got a primary signal from the BMW, so it's receiving a ground command, which, you know, descends it grounds our static supply voltage through the coil and commands the coil on. So we know that the source has to be a ground, right? We know that it's not a power. It can't be a power, because then our source, once that connection is made, when the gatekeeper decides to close the gate, well, that's a bad analogy. When the gatekeeper decides to complete the circuit, we're not getting power to the coil. We are getting ground. So the source has to be a ground. So we're going to go to our good one. We're going to ground one of our leads, and we're just going to test, right? Make sure that our meter is on, and we're going to see which pin is our source, our supply. Another word for source is supply. It just makes it easier for me. The gate, another word for gate, is the command. That just makes it easier for me. And the drain would be the output, in my opinion, if it makes it easier. But the actual words would be, you know, source, drain, and gate. So trying pin number 1, we have no continuity to ground. We know that pin number 2 is our drain, no continuity. Pin number 3, good continuity to ground. So we know that pin number 3 is our source. Pin number 2 is our drain, and pin number 1 is our gate. That's our command, and there should be no continuity to ground. Now we're going to test our bad one. Our bad transistor, we're going to check for a good source supply. We have good source supply from ground. We have no continuity to ground on our excuse me, on our drain, which makes sense because all we saw was static voltage in the waveform. We saw no command, we saw static voltage though. There's no continuity from the ground supply to our drain, our output. Pin number 1, nothing. No continuity to ground from our pin number 1 to the gate, the command. So I want to see if this thing's shorted somehow. So what I like to do, there should be no continuity between these pins when they are not activated. If the gate, if the command was receiving a supply, a voltage command from the ignition module or the ignition IC, whatever's responsible for the ignition, it could be a 5-volt thing, that would close our source and our drain, right? So there should be no continuity between any of these on our good one. So I'm doing from 1 to 2, no continuity. From 1 to 3, no continuity. From 2 to 3, no continuity. Get what I mean? With no command, there should be no continuity. If there was command to our pin number 1, it would close our 2 and 3. But there's nothing there. So let's go back to our bad one and try 1 and 2. Sorry, just checking my meter. We have continuity. By mistake, I had this. I'm going to have to retest our good one because I had this slightly loose, and when I checked it, it was slightly loose. So we're going to have to go back to our good one. Do the same test over and make sure we didn't skew our test by, fat fingering. I'm not gonna edit that out. By fat fingering the probe here, and I've just confirmed that our test was good. We have no continuity between any of the pins, but on our bad one we have continuity between 1 and 2. 1 and 3, no continuity. 2 and 3, no continuity. So our gate and our drain are shorted to one another. So a shorted coil can cause overcurrent direct to our IC or whatever is responsible for our ignition control, unless there's a diode in the middle. And I do see something, microscopic down here. If it's a diode, I'll be able to test it, but I think it's worth a shot. Let's put a transistor in this thing, see if it works. It won't hurt not one bit to find out. All we have to do is change it out, connect it, and run it. All right, so we have a donor board courtesy of our friends over at Specialized ECU Repair. If you guys don't remember, I made my first ever circuit board repair video was with Jose over there at Specialized ECU Repair. They were kind enough to send us this donor, and ironically enough, this actually has a misfire on cylinder number 3. I was able to look at the diagram, find pin 14, which controls ignition coil number 3, and using the same test that we used before, the continuity test, I was able to find which drain or which output is responsible for number 3 ignition coil. So I marked it with an X. If you guys can't see it, this is the one that we are avoiding. Another thing is that I had to kind of lift the board off of the plate beneath it just slightly in order to inhibit that kind of heat sink effect that it's getting from being attached to the board directly. So if we were to leave the circuit board on here attached still, all the heat that we could apply is just not going to work. It's just going to fail. So I stuck a little screwdriver in here just to kind of lift it up. And we're going to try to take off one of these transistors that's not number 3 and hopefully use it for our problem module on our X5. So let's get started. I'm using that little Fleabay kit that I told you guys about in the earlier video. It's the Auto XL 8586. I have it on 400 degrees Celsius, I believe. And yeah, it gets the job done. I have it set on fan speed 6. And we're going to give this a shot. I'm going to try the outer one first. I'm just going to hover over it a bit until I start seeing some flow. I usually check with the needle to make sure it's completely liquidated, the solder. And since it has an adhesive underneath it, it becomes a little difficult to remove. Well, you know, to a lot of people, I guess. If you're not careful, you won't be able to see that it is flowing, and it is liquidy now. It's actually moving freely. Wow. So that one did not have a lot of adhesive going on in there. But that came off like nothing. So good for us. Now we're gonna bring our problem board, and I'm just gonna lift the corner just a tiny bit as well in order to facilitate this transfer. I may need to do the same deal with the screwdriver. I can see some flow happening already. And we are loose almost. Just gotta make sure that my pins are completely loose. And they are. Oh, no adhesive, nice. It's just on the sides. It's not, they weren't crazy about it. And yes, came back on. Boom. Now what we want to do is flatten out as much as possible this area. Once we lay our new transistor on, we don't want any of that to cause us problems, so I'm just gonna gently scrape off this adhesive here. And anywhere where our soldering iron might come into contact. We just want to flatten it out. We're not scraping off solder mask or anything like that. And wow, I don't even know if you guys were able to see that. That sucks. But we're gently going to remove this solder that's on the board, on those pads. And for that, I'm using solder wick with flux. So let's put some flux here, clean this all up. Oh, probably would help to put on my fume extractor here. And it won't be perfect. I'm gonna have to cover the camera with my hand, unfortunately. Oh wait, let's do this lefty. And that's good enough for me, honestly. Now we're going to want to grab our new transistor, and hopefully it's flat as well. But in our case, it is not. Let's not get these mixed up. And I want to solder it on. I'm not going to use hot air to put it back on, but before we solder it back on, we need to make sure that this pad is nice and flat. I'm going to put some flux on it first. That's what I usually like to do, is at least flatten it out. I would like to put some solder, use a solder wick to remove that excess solder, simply because I don't know what solder is on there now, and solders don't usually mix well. But in these situations, it tends to be a little harder than it looks. I try to heat it up first. Hold on. Let me put some more flux on there. I usually like to heat it up first. And once we get it a little heated up, put that solder wick back in there. See, when it gets nice and shiny, that's when it's flowing. And solder flows to where the heat is, so it goes into the solder wick. It wasn't all that much. But yeah, we're going to put this sucker on. And yeah, too much flux. It's the way we roll. Let's put this sucker on. And knowing me, it won't be perfect. And I should be wearing gloves. So let me grab a glove for my left hand. I'm going to be grabbing the solder with it. I know it's probably not that good enough sometimes, you know, just one glove, but for me it does the job. Of course. It may work out for me to put this on first, the gate. Let's just leave that there temporarily. And usually I would be positioning this to my liking to make it more convenient, but since I have the camera in only one spot, I have no choice but to go lefty with it, and I'm gonna need another glove. So we're going lefty with the soldering iron, and we're heating up the pad and pin at the same time and dropping some solder in there. Same thing on the other side. Hold on. And I'm overstaying my welcome with this flux, that's for sure. I'm gonna try this side again. Yep, overdoing the flux. overusing the flux. That's me. This is probably the worst video I've ever done. But to clean it up, we're going to use a little bit of heat to kind of soften up that flux. And I'm going to use a little brush. Where is my little brush? With some alcohol. And we're going to do the same thing out here too. But yeah, I'm going to hit that up with some compressed air, but we should be good to go. Alright, so we are back at the vehicle and we've temporarily put on the DME before we go ahead and seal it and put the heat sink crystal gel back on so that it can properly dissipate heat. I've got the little U-scope hooked up and we're going to check to see if we got ourselves a signal. I wanted to use the Pico, but it is indisposed at the moment. But not to worry, we can still see what's going on. Feels nice and smooth. I've got no lights on the dash. And nice. This is a confirmed fix, my friends. Nice and smooth. Well, almost nice and smooth. Well, I hope you all enjoyed this one as much as I did. I will have to work on my process with removing that transistor. It's not that easy with the way it's built, but none of it is. I mean, I've had much worse actually when it comes to removing chips and all that good stuff. But anywho, I hope this is useful to everyone who has seen it. If you guys have any questions or if you'd like to leave a comment, go ahead and do so. And if you like what you see, consider subscribing. As I go improving, I'll go ahead and share it. But for now, that's not too bad for my first time on this one. It is a good thing that they changed the coil. I'll say that much. Thank goodness they changed the coil, at least that one, because that could have been bad news. If you guys are ever having a driver issue with a computer, and you should be changing, along with the repair, you should be changing out that coil for a new one as well. And I never put a coil without putting a plug as well. So yeah, thanks for watching. I appreciate you all. Consider hitting that like button, leave a comment, as I said before. Tell me what I missed. What did I screw up? I know I screw up a lot. So be sure to leave it in the comment section. Remind me. And I'll catch y'all next time. Thanks for watching.